I actually never thought that I need to explain what an array does in one of my tutorials on my music channel, but today I will do exactly that. Use my code Polarity in the shop to save 10% on the price and support my channel. So here I have the small polygrid set up inside Bitwig Studio 3.2. And I'm using here the new interpolation with the steps, as you can see. And this is how it sounds. So nothing special. But I try to use the array now and try to come up with some nice stuff. So I'm deleting here the connection between the output and the oscillator, or the output of the filter here. So we have now this module here. It's called array, recordable lookup table. Okay. So, and this word table exactly makes sense because I try now to explain what this array does. So we have an input here, read phase, write phase, and we have actually an audio input, and we have a trigger input, and we have an output. Okay. So with this array, we have data slots. Okay, and how many data slots you can choose here on the right or on the left side in the info pane. At the moment it's 16 data slots, and you can go up to 1024 data slots. Okay, so this is basically like a table. So when we go here to the browser, I found this small image on the internet, and it's actually for wavetables, but it's exactly enough to explain what this array does. So we have here data slots, 1024 data slots. And on this table, you can see a data slot at this rectangle here, at this square, basically. So we store in each of these squares a value. And the value is basically some point on our waveform. So we have an audio input here, and then we take, or we input an index number, for instance 1, and this array module exactly knows, okay, the user wants to record some value for the square 1. Okay, which value? Look at the input, it's audio, and then take one sample or 1 point from the input waveform and store it into the data slot. Okay, so and we do this for all the slots in the array. In this case, it's 1024 slots. So we sample 1024 data points from our input waveform. Okay, so all we do now is we take the audio input or output of this patch and hook it up to the input here. So we have now something we can sample. And then we need, of course, something to change the index number, the slots where we want to store something, right? We want to store something in 1, then 2, then 3, then 4, and so on. And we can do this by using some kind of input. So we can take all the modules here inside the grid to actually change this number. Okay, so I'm going for an envelope, because I tried this before and I think it's pretty fun. I'm using the AD envelope here. Why? Because it's loopable now. That's also a new addition to Bitwig Studio 3.2. You can loop this envelope. Okay, so every time I trigger my keyboard, basically, let's bring this down here to 0. Okay, so it's completely linear. When I trigger my keyboard here, as you can see, this dot goes up, right? And this dot is also represented by a number. So when we take here the output, it's actually the envelope output. You can feed it into the read phase, and you can also feed it into the write phase. Okay. So now when I press the key on the keyboard, we generating a number from this envelope here. We use this number to change the index, so the array knows exactly where we want to store something in the array. and we want to store the waveform that's coming from this patch here. And we want to store this value at this moment in time in one of the slots, okay? And because we are using the envelope output here for the read phase and the write phase, we exactly read at the same place where we write something or we wrote something before into the grid, right? And to make this happen, we also need something to trigger here, this array. And I'm using an LFO here. I'm using an LFO, and I'm using here this wave-shaped teeth, basically. And I'm going out into the trigger, switching this to kilohertz. I'm going up to 32 kilohertz. So this is basically our sample rate. So every time we trigger this array with the LFO, we sample something. And every time we sample something, we take the audio input, take the number from the waveform, and write it at the index we gave this array via this envelope. Okay, so the envelope decides which slot to take. The input decides what value we want to store, and the sample rate basically decides when something happens. Okay, so now we can hook up here, I think, the output, or let's actually use an oscilloscope here at the end so we can see what's happening. And we take the output here. Okay, so now when I press the key on the keyboard, you can hear it's basically the same output as before. A lot of crackling is happening, but that's okay for now. But we change basically the index of the read index the same way we change it for the write index. So it's every time the same. But when we actually use a second AD here, the output for the write phase, now we can change the index reading differently from how we write something, right? So now when I change the read speed, we can change some kind of pitch, the pitch, because we are reading the index faster than we are writing to it. I hope this makes sense. It's just like a tape recorder where you recorded something slow and then you play it back much faster, right? But in a digital way, with instead of tape, you using basically an array. And now we can activate here this loop function, so we have a continuous flow of audio. You can also hear that the resolution changes a lot when I change these this envelope, because the resolution is not only decided by the triggering here, by the sample rate, also by the playback speed. So when you sample something like with 8-bit and you play it back much faster, the resolution becomes better or higher, because you just squish it together. I hope that makes sense in some case, but the sample rate is not so important when you basically pitch stuff up. Okay, so that's why we used to sample instruments in the early days at much lower frequencies, so we can pitch it up inside the sampler to have a better resolution, right? So this is the same concept. What we also can do is we can introduce some kind of logic. So we can choose to record something at will. So let's use a button here and actually use this for the right phase. Go in here. Or actually go in bottom one. So. And then go with the audio in here and this. And this, then we can call this here record. And now we just record when we hit this button. So when I hit some key on my keyboard here, I actually just played the output buffer. So there's no audio coming through. I can completely remove here the audio input or remove this audio input here. So it's just the data stored in the slots inside the array that are playing. But you can, as you can saw before, you can basically use this in here. You can use this as an audio pitch or to pitch some audio up or down in real time. So when we move this here basically again and go with the audio in here and use this for the right phase. And we use a steeper slope here for the read than for the write. Then the output is always pitched up. So 425 is the original. So this is the original pitch. And now we have always a pitched up audio signal. So you can not only use this to repeat something, you can also use it to pitch audio up and down. I know it sounds a bit crushed, but you can optimize it by using a higher sample rate here maybe, and or a steeper envelope for the write phase, so we can write more information faster. So there's much stuff to explore. It's actually pretty fun to play around with the array here. And I hope I explained everything pretty well. I know I repeated myself a lot in this video, but I want to make sure that everyone gets what I'm trying to explain. It's not so a complicated module. I think you can do a lot of stuff with it. And you don't need to use an LFO for the triggering, and you don't need to use an envelope here for the write and the read phase. You can use all kinds of modules in the grid. As always, just feed something into something and see what comes out of it. So was just my attempt to try to explain what the array does. And I think you can already see that's a pretty powerful module. And it will be pretty fun to actually explore what you can do with it in the future. So I hope this was pretty much easy to understand what I'm trying to explain. If you have some questions, of course, just tell me in the comments below. I try to answer everything. This was just my first attempt at trying to explain what this module does. I think it's pretty low level, but when you get the concept, you can do a lot of stuff. As you just saw, you can pitch up and down audio. You can use it as a delay. You can use it to bit crush stuff. You can use it to make reverbs. All these kinds of stuff you can do with the array, where we can just store values or values from waveforms and then recall it in a different way. Maybe you can also do something like a reverse. You can reverse audio in real time, something like this. But I will make more tutorials on this in the future, of course, also presets for you to download. And yeah, tell me what you think about this video and leave me a comment down below. Leave a thumbs up, subscribe to the channel and subscribe to Patreon. And I see you in the next video. Thanks for watching and bye. In the current time with the coronavirus, a lot of creators struggle to survive. So I want to place an ad at this point in my video for my man Taturahex. And he does graphics, or in fact covers. So when you plan to release something in the future, then maybe give this man a follow on Instagram. The name is Taturahex, and he sells these covers for $30 each. So maybe it's something for you.